Welcome to Revolution Against Evolution. I'm your host, Doug Sharp. Today we are at the Institute for Creation Research in Santee, California, and we've been part of a genetic research project that is just starting up. And Walter ReMine is I think, one of my favorite authors. He's written a tome which really takes some getting through. I make it required reading for people who are going to be serious, want to seriously know everything there is about genetic information, and they want to know it from a creationist perspective. Your book is called Biotic Message, and I picked this up at a conference a couple of years ago, and it took me quite some time to get through it. But I was really amazed at the information in it. It was this kind of information that really turned my tide many years ago, when I was just trying to figure it out for myself in terms of how life is all put together. And the information you have in your book is a whole lot more amplification of that experience that I had when I was just a freshman, senior in high school and a freshman in college. So I really thank you for your efforts in putting that together. And I guess I have a couple of questions that I might want to see if you can explain to our audience. One of the things that you pose to evolutionists that I don't think it has been answered adequately is what has been called in the literature Haldanes Dilemma. Do you think that maybe you can explain to the audience what they are talking about in terms of Haldanes Dilemma?
Sure. Thank you, Doug. I'll try and explain it as simply as I can. Haldane was a famous evolutionary geneticist who discovered this problem back in the 1950s, 1957. And the problem now bears his name. The problem is called Haldane's Dilemma. Now, using the figures that he calculated and the theory that he developed, and a few other figures that come simply from evolutionists, you can calculate that in given 10 million years, a human-like population, or the presumed ancestors to humans, could substitute no more than about 1,666 beneficial mutations. That's not very many. And with that very limited number, evolutionists would have to explain all the adaptations that humans allegedly evolved during that 10 million year time. That's a lot of time. That's 2 to 3 times this alleged split between humans and chimpanzees. And you'd have to explain with that limited number of substitutions the tripling of brain size, upright posture or dexterous hands, speech, language, appreciation of music, poetry, and all the rest of our unique human adaptations. Can it be done with 1,666 beneficial mutations? That's a problem for evolution. And it's also a problem that they've never been really all that forthright about with the public. It's a very simple issue that the public can understand and should have been told about a long time ago. But evolutionary geneticists didn't. And that's another part of this issue, is the lack of forthrightness from evolutionary geneticists.
Now, with every beneficial mutation, is it true that there's a cost to it? It seems to me that if you're replacing a gene in the chimp, you're losing something from the chimp to create something in the human. Is that sort of how it works, or that's a dilemma on top of the Haldane's dilemma in my mind, is that actually converting something from one organism to another is sort of like driving a bus down the street and trying to convert it into a submarine while you're driving it.
Yes. Not a bad analogy. I kind of like that. Yeah. There are many problems with converting one life form into a different one. There's many problems there. But Haldane's Dilemma, in a sense, brushes those more difficult problems aside and looks at something very simple. The issue of substituting one gene with another gene that's different from it by one mutation. That's typically the issue, as evolutionists explain it. That's how they say evolution occurs, is you get a mutation that's new, it's rare in the population, and then it increases in number from being few in number, say 1 or 2 individuals have that mutation. It increases in number till the whole population contains that new mutation. So it increases from 1 or 2 individuals to maybe 50,000 or 100,000 individuals have that new mutation. And that step requires extra reproduction rate. It requires not just a minimal reproduction rate, it requires extra reproduction in order to cause that increase. Okay? And that is literally what Haldane identified in his theory. Which we now call the cost of substitution. Okay.
Yeah.
And one way of thinking of it is to grow something from few in number to many. That growth rate is limited by the reproduction rate. The higher the reproduction the species has, the faster that growth can occur. But if a species in question only has a low reproduction rate, like humans and apes and whales and bears and elephants, a number of the higher vertebrates have fairly low reproduction rates, then that increase can only occur very slowly. And that's the kind of problem that Haldane identified, is that for the higher vertebrates, this growth occurs very slowly, and that slows down the process of evolution. In order to substitute one mutation after another, or even substitute many at the same time, is limited by the reproduction rate of the species.
So what you're really saying is that evolution happens faster for organisms that have a higher reproduction rate, like bacteria, for example.
Yes.
Bacteria, we should be overrun by bacteria as an example of how evolution works. If evolution is true, then we shouldn't get higher organisms, we get lower organisms, because they'd compete out the higher organisms. Why would you evolve something as complex as human beings when the simplicity of the lower organisms are favored? Is that really what's going on?
Well, arguments like that can be made, sure. That's a problem for evolution. Haldane's Dilemma, he tells us that organisms like mice, for example, which have high reproduction rates and short generation times, they can evolve faster. They can substitute beneficial mutations faster than a higher vertebrate like humans or whales or elephants that have very low reproduction rates and long generation times. And it's in these higher vertebrates where the Haldane's Dilemma is most problematic. Okay, the theory that Haldane developed can be applied to any species and any substitution, but it's most problematic for evolution for the higher vertebrates.
So what would you say is the implication for evolution theorists who are trying to explain this? How do they attempt to explain this away?
Well, traditionally what they did is not really solve it. They believed they solved Haldane's Dilemma, but I'm claiming they didn't really solve it at all. What they did is confused it. They confused the problem, they confused the terms of the problem, and because of that they developed a bunch of false solutions that don't work. And that's in the process of being cleared up now. That's what I'm doing in the evolutionary literature, is clearing up this issue of Haldane's Dilemma. And showing that their current solutions don't work. Now, what they're going to do after that, who knows? I'm having trouble getting the evolutionary geneticists to address this problem and take it as real, accept it as a real issue, a real live issue. So that's where we're at right now, is getting evolutionists to simply face the issue and face the fact that they've traditionally confused it. They haven't communicated it well to the public. They haven't really communicated it to the public at all. They communicated it in their technical literature to each other in a very confused manner, so that even students of evolutionary genetics today, when they go back and look at this literature, they don't get clear answers. They get confusion. And evolutionists haven't faced that. At this point, that's what they have to face up to, is their lack of forthrightness about this issue.
Would biology students ever encounter mention of the Haldanes Dilemma in their freshman biology class? Would you even have it addressed or talked about, or when they're talking about evolution?
That's uncommon today for evolutionists to talk about it in their textbooks. I think it was more common, a little more common in their evolutionary genetics classes. They talked about it some maybe 20 years ago to evolutionary genetics students. Mm-hmm. But not to general evolution students. I don't think even then it wasn't talked about much, and even less so today. It's kind of dropped off the radar screen. It's dropped below interest to evolutionists. They really don't talk about it much anymore, believing falsely that it was solved.
And because they've been fed the line that it's been solved, and then they don't even pay any attention to it, and so it becomes a non-issue to them. But what does it mean to us as creationists? How can we use this and maybe bring it to the forefront so that the common person can understand it and maybe use that as a mechanism to get people to understand that creation might be true?
Yeah. Well, creationists can cope with it simply by understanding it. And it's not that hard to understand the basics of the problem. That is, 1,666 beneficial mutations isn't enough, doesn't seem to be enough to explain all our human adaptations. Let me explain that argument a little deeper.
Okay.
What we would do then is we go out in nature and we examine beneficial mutations, or at least what evolutionists call beneficial mutations, that we see out in nature.
But not many of them.
There's not many of them. And, you take a typical example would be the Galapagos finches. The finches that exist on Galapagos Islands have different beaks. Some of them are stubby, short beaks, thick, and some of them are narrow, long beaks. They're different sized beaks. All these finches can interbreed, as it turns out. They're all what creationists would call the same kind, or the same monoberman would be the creationist name for it. But evolutionists say these different finch beaks were produced by beneficial mutations that occurred somewhere along the line. So what the creationists can do then is say, all right, evolutionists have claimed these different finch beaks are the result of beneficial mutations. Let's say they were caused by one beneficial mutation. We don't exactly know yet how many were involved, but let's say, for the advantage of evolutionists, let's say it was one beneficial mutation that changed this finch beak in such a beneficial way. Okay? Wow, what a powerful beneficial mutation that it could change this finch beak in such a beneficial way. Okay?
Yeah.
Now, what we do by that is we establish some measure of how powerful a beneficial mutation is, or how unpowerful it is. Mm-hmm. The question is then, are 1,666 of these like finch beak things, mutations of that much power, enough to create a human out of a simian?
And what we're talking about in terms of a mutation, are we talking about a point mutation, where you're just changing one nucleotide to produce another nucleotide? Or are we actually taking a piece of genetic code and pasting it over here to do it?
Very good point. According to evolutionists themselves, They claim that most substitutions in evolution, most beneficial substitutions, are point mutations. Each one is a single nucleotide, a single DNA nucleotide mutation. So that means that Haldane's Dilemma, we're talking about nominally about 1,666 nucleotides, beneficial nucleotide changes to turn a simian into a sapien. Now, that's not very much. That's very little DNA change.
Well, it's sort of like changing in a sentence a period to a semicolon.
Yeah, I suppose.
Or, taking your language and, changing the phrase, I am a pig to I am a dog. And you've got 2 point mutations there.
Yeah. It's not very much. These
And when you take a look at the entire human genome, we have how many base pairs that we're dealing with? 3 billion. And so we're talking about 1,666 point mutations in that had to have changed from, we're talking chimp to human?
Or something like it.
Okay. And that would cause the changes that we need to produce a human being. I find that incredible. How do you actually justify thinking that way? I really don't know.
It baffles me how evolutionists cannot take this problem seriously. And so I really appeal to creationists, anybody out there in the audience, who can understand that this is a serious and interesting issue to look at. And that you can understand enough of it already. You don't need to know population genetics to understand this. Just go up and pressure evolutionists to answer it. Address this issue and answer it.
And that's the question. Do you know what Haldane's Dilemma is? Maybe they don't even know what it is. And if you can inform them and educate them a little bit, tell them, read up on it. I'm sure you can find some discussion on the internet about it.
Yes. My website has a bunch of material.
Oh, yes. What is it? What is your website?
Oh, it's got some long name. Just look up my name, Walter ReMine, on the biotic message, and you'll find it.
Okay, well that's good. I'll have to reference it on my website.
Okay.
So, this is something that you, either as a Christian believer or a non-believer, should add to your list of questions that you need to ask yourself and other people concerning the theory of evolution. And we're dealing with issues here that are really eternal, life and death. Who are we? Where are we come from? Where are we going after we die? These are important questions that we all have to deal with. We're not going to get out of this life alive.
Sure.
And to have the wrong answers in this situation has eternal consequences, certainly. And so this is one powerful piece of evidence that God is creator and that He made us, and that the traditional evolutionary explanation doesn't make any sense. So, what else relates to Haldane's Dilemma? You said you developed a cost theory, which tells you can actually make some calculations concerning this that will show that populations of genetic information deteriorate. Is that really what it is?
Yes. There's an issue related to Haldane's Dilemma called error catastrophe. And that's where a population receives harmful mutations faster than the population can get rid of them. So the harmful mutations accumulate in the population and it genetically deteriorates. Sometimes it's called mutational meltdown. The population goes through genetic meltdown where it loses information, and eventually, if that keeps up, it'll go extinct.
And
now, you can calculate using measured mutation rates, rates of mutation that we can measure in organisms today, and you use their known reproduction rate, which you can also measure today, and some very simple things having to do with their genetic model, the fact that they're diploid and so forth. And you can calculate whether they're in error catastrophe or how close they are to it. Now, it turns out that humans are precariously close to error catastrophe, the human species. Perhaps we are even in error catastrophe, where we are genetically melting down, losing information. And how do we know that? Well, it used to be thought that humans had each progeny, each newborn. Of course, it inherits the mutations from its mother and its father, and it also receives additional mutations. And it was believed that those additional mutations are about around one new mutation per progeny. Well, it has since been measured that in humans, that mutation rate is somewhere between 150 and 300 new mutations per progeny, depending on which source you look at. And that's an incredibly high mutation rate. It's hard to imagine using a mutation rate that high. It's hard to get away from the conclusion that humans are not in error catastrophe. It looks very much like we are, given those figures.
Come, Lord Jesus, come.
Yeah.
That's really what you're looking at.
Yeah.
That's a scary proposition, is that, and what it also indicates to me is that even beyond the error correction repair mechanisms that we know about, there must be some life-sustaining vitalism that's keeping us going this long.
Well, that's that's a thought. Yeah.
Maybe God is working miracles all along just to keep us alive, to sustain us. It's a mind-boggling thing.
This issue of error catastrophe, that's not something I am alone in saying. I am raising it as a possibility. I've taken this, I'm the creationist who's come along and taken this issue, raised it up and saying, humans and other species, lots of species, most of them, might actually be in genetic deterioration now. Genetically deteriorating, in error catastrophe, in mutational meltdown. That's a real possibility. I'm not saying we are. I'm saying it's a thinkable, believable, even believable concept, given the mutation rates that we're measuring. Okay? But I'm not alone in that. Leading evolutionary geneticists are saying the same thing. James Crow, for example, is one of them. He's a famous evolutionary geneticist who believes humans are in error catastrophe now. And he's not alone either. There's others. A famous example is an evolutionist named Alexei Kondrashov, who wrote an interesting paper, a fascinating title called, the title of the paper is, "Why Have We Not Died 100 Times Over?" And really, I mean, it's an apt name for the title of his paper, because he's discussing, given these high mutation rates, 150 to 300 new mutations per progeny, why have we not gone extinct many times over?
Well, Walter, we've run out of time, but I thank you for joining me on Revolution Against Evolution.
I'm delighted. Thank you.
And I'm going to have to invite you to Lansing so that we can talk further and do a few more shows together. It's been a delight.
Great.
We'll see you next time on Revolution Against Evolution.